Okay, so this supercapacitor has been running this motor for over 10 minutes, and I've got this connected to show its voltage and the milliamp draw. It's drawing 20 milliamps to the motor. But what I really want to show here is this fast charge potential. This is what's really cool and what has my interest about these. Not only do they last longer than batteries, or they should in theory, but your ability to quick charge these is really, really fascinating to me. So I'm going to go ahead and put this up at 30 volts and give this 10 seconds. Alright, close enough to 10. I hear it bubbling away in there. I really don't want to damage it. But after just, less than 10 seconds of charging, this thing is off and away again. And that is what really intrigues me about these setups. So anyway, folks, it's all very fascinating. If I had a power supply that could deliver more amps, I would actually just keep this down at like 2 or 2.5 volts and just crank the amperage in to fast charge this. But it's all very fascinating. The big secret to increasing the capacity on these is surface area. I've taken apart some supercapacitors, commercially available supercapacitors, and when you look at the amount of surface area inside of one of those, it's just intense. I mean, just layer after layer after layer, and that is really, I feel, the secret going forward, getting away from these thick plates and working with thinner materials and increasing surface area. I think that's what it's all about. Okay, so this video is going to go over how to make these credit card size capacitors, and basically what I've done is I've taken these two pieces of aluminum and I've really roughed up the surface. So these have been sanded with a heavy grit sandpaper to prep them for this graphene layer that we're going to paint onto there. So okay, so one of the first steps is to take some of this activated carbon, and I'm going to run it through my coffee grinder. And basically I'm trying to get a certain size. So I have two sizes of screen here. And again, I don't know that any of these steps at this point are crucial because I haven't built all that many of these capacitors yet. So I'm still experimenting. I've got this stainless steel mesh. I'm going to try all kinds of stuff going into the future, but so far this is the design that's been working well for me. So I've got two sizes of mesh here in the screen, and basically that's to screen out the activated carbon. If you take a look at this activated carbon, it's pretty chunky, and you want to break these chunks up into smaller pieces, but I still want to try to maintain the surface area across this plate. So that's the purpose of this step. So by basically grinding that and then running it through this screen, I'll be able to size this stuff into two different mesh sizes. The really thin powder stuff I'm just going to wash down the drain. Okay, so we'll separate the screens, and what you'll see is the stuff we're actually going to be using. And we're going to go ahead and use this fine material here. So we'll put it in the bowl. That's the stuff we actually want to use. So they're all about this perfect size, just right. Okay, so before I actually lay down the graphene layer and sprinkle the activated carbon on these, I want to prep these with some wire leads coming off. And I've done some experimenting. I'm going to seal mill this in the end and try to vacuum it down with a vacuum seal. But in order to do that with any level of success, I've tried different wire with this seal process to try to get something I can get a good seal with. And so far, believe it or not, the wire that seems to work best is this Ethernet cable wire. So it kind of looks like telephone wire as well, but I took apart an Ethernet cable and got this wire out of it. The insulation around this wire actually melts and seals into this to form a better seal. So I'm going to go ahead and prep these plates with some leads coming off on the positive and negative side. Okay, so I'm going to drill some holes in the corner Okay, so I'm going to put some holes in the corner. I'm going to put some rivets through here to hold down the wire and make a good solid contact. So let's go ahead and do that. Okay, so after drilling, the aluminum kind of sticks up a little bit here, so I'm going to sand that off. Okay, so orange is going to be my positive on this one. So I'll go ahead and prep up the orange plate. Now again, one side of this is really roughed up, and I want to put the wire coming off the back side of that like this. So I've got these little rivets, put that through, and give myself a little more wire to play with. There we go. So yeah, I'll put this through, and then I'm going to wrap this around it, like that.
Este tipo de tradução especial está sendo útil? Espero que sim. Contribua com o canal, faça Pix, R$10 mensais, ou como preferir ajudar. Também, curta e se inscreva. LegDub Universe. Obrigado.
That should be good. Now I'm going to just go ahead and work that through. Okay, so that made a very nice connection. You can see it's sticking up here on this side. I'm just going to take these little wire dikes and clip this off. It's fairly soft aluminum. There we go. So now we have a nice contact coming off there to carry the current off of these plates. So now I'm going to go ahead and prep this side. By wrapping that around a few times, the rivet pulls itself up tight. It really bunches the wire and kind of crimps it into place. Gives you a pretty good solid connection coming off of here. So there we go. Those are ready. Okay, so we're going to go ahead and mix up this graphene powder with a little bit of this polyurethane. So it doesn't take very much. Every time I've done this, I've made too much. So I'm just putting a little bit in here. A little bit of this goes a long ways. And see, even now I'm tempted to add more of it. Based on past experience, I think I'm going to leave it right there at that. So I'm going to add just a little bit of this polyurethane. This really forms the binder. And when we go ahead and work the activated carbon granules down into this binder, it really does give it a lot of surface area. Okay. So that's ready to paint onto the plates. I'm going to go ahead and put this away because I know my tendency will be to knock this off all over down my pant leg and onto the floor. Don't want that to happen. Alright, so I've got a little brush here. I'm going to go ahead and brush a layer. Wow, look how that spreads. So we'll split this between the two plates, and there'll be plenty to hold the activated carbon into the mix here. So okay, that's looking pretty good. So the next step is to sprinkle them. So we'll just go here, and I just want to sprinkle an even amount on both of them. I'm going to start out by going sparingly here a little bit because I want to make sure that I get a lot of coverage. This last bit, I'm going to go ahead and really pile it up, and then I'm going to actually press. I'm going to put on a glove and press that down onto those plates. Go ahead and slide it shot. Okay, so now that I've got this glove on, I can go ahead and press this onto the plate. We want to make sure we have some really good adhesion between the bottom plate, the graphene, and this activated carbon. Okay, so it's another day. I had to let these sit and dry, but the polyurethane is completely dried out now. And you can see that we have really good adhesion to that graphene base that we painted onto there. So it's just what we want. We want to knock off any loose particles. And these plates are now finished. Okay, so now we're going to take this in and we're going to just flatten this section of wire here so that when we seal nail the bag, it gets a nice tight seal. Okay, so I'm just going to clip the wire leads coming off of here. They don't need to be this long. Now if this was going to be a high amperage design capacitor, we'd have to have more of these attachment points to the plate. Okay, so you want to be careful doing this because if you hit this too hard, you'll cut right through the wire. The hammer will shear through it. So I'm just going to line this up here and I'm just going to give it a little tap. Work on flattening out a section of the wire, and you can see I did that. This is very nice and flat through there now, but you don't want to hit it so hard that you break through. So that one's ready. Do the same on this one. perfect. I can just start to see a little bit of copper coming through the insulation there, but that's just right. Okay, so I'm going to create a separator here, and this is just a heavy-duty paper towel. And you just really want to make sure that it's thick enough and heavy-duty enough that none of the little angular pieces stick through or break through the paper towel and short between the two plates. So as long as it's adequate to make sure that that doesn't happen, you should be fine. So I'm just going to lay this out here and cut this, and I'm going to cut it a little larger than the plate because again I don't want those plates touching. Okay, so for the electrolyte I'm using phosphoric acid, and I got this off Amazon from a seller called Dudas, and I actually ordered the 1 gallon bottle. That's what I paid for. They sent me this 950 milliliter bottle. I've never been able to resolve it with them. I've sent them pictures, everything else. So you order this, you may find yourself, at least I would not recommend ordering the gallon size. You may end up with one of these instead. If I can find a good link, I'll share that in the links under the product links over at laserhacker.com. But anyway, we're going to use some of this. I'm just going to pour a little bit in this container, and I'll dab it onto there with a brush. Okay, so we have our positive plate down here. Really, it's just the colors that are denoting whether it's positive or negative at this point, but let's go ahead and start to apply some of this. And you just want to just dab it onto here and let it seep and work its way through the paper towel. We have all these little pieces of activated carbon, and we just want to make sure we have plenty of electrolyte on here. That's looking good. Alright, so we have the separator. We're going to go ahead and put this piece on over here. Just readjusting a little to make sure that there's plenty of separator everywhere, and that's all even. I want the edges even along here and on the other side. Make sure they're all lining up well. A little bit crooked there. There we go. I'm going to clamp this just to hold the pieces together. And you can see some of that phosphoric acid oozing out and dripping here on the counter. So I'll have to do a thorough cleanup here when I'm all done, but I'm going to go ahead and start to clean up the excess. Okay, so now I need to create the sealed bag to put this in. So basically I'm just going to measure this out and create a bag that will hold it. So I'm going to go just a little larger on the dimensions. So I guess first of all I'll establish the length. So just cut this off here. There we go. So that seems about right. Okay, now we need to seal it down the width. If I don't get it right here the first time, I'll just seal up another one. It's pretty good. It could be a little bit closer. That looks perfect. So I've already wiped this off, so I can touch the plates now. Got rid of all the excess phosphoric acid that was on those plates. Now we'll just slide this down into the package here. There we go. And we have the two regions that we hammered flat on the wire right where they should be. Okay, so that looks good. So first of all, I'm going to go ahead and start to seal this side where we already hit the wire down flat. And it seals the bottom against this wire really well. In fact, when I've pulled this, the covering strips off and leaves the plastic covering, just breaks off, the copper slides out. So it gets a really good adhesion to the insulation on this Ethernet cable wire. But I do want to do the other side because you can see that this side, you know, it melts into the covering, and then you need to flip it over and make sure you do both sides. So anyway, we'll flip it around, do the other side here. Okay, so let's seal this side.
Este tipo de tradução especial está sendo útil? Espero que sim. Contribua com o canal, faça um Pix, R$10 mensais, ou como preferir ajudar. Também, curta e se inscreva. LegDub Universe. Obrigado.
Okay, that looks really good. So I've done a lot of testing. You'll have to play around with your sealer, and this is just a sealer I picked up on Amazon, but you'll have to play around with your bag, the temperature, the sealer, and what I do, let me just show you what I did here. That way you'll get an idea as to how I came up with this. So basically, and this wire is not even flattened, so this will just be a quick test to show you what we're shooting for. Okay, so you've got your wire coming into your bag. And basically what you want to do is when you get your wire in your bag like that, you want to blow up this end kind of like a balloon, see if it holds air. So I just was blowing on this, it holds air just fine, so that's good. Now we didn't seal both sides in this, but even if just one side, if you pull on this, you can see that it really does grab. If I had done both sides, it would have grabbed a lot more. Let's go ahead and do both sides over here on this side, and I'll show you what I mean. So, we'll do the one side, flip it around, do the other side. Let it cool down for a second. Still really hot. Look at that. So we left the wire insulation and stripped the copper wire. So that's pretty impressive. So anyway, that's what I've come up with sealing this in the container like that. Now what I'm going to do is I'm going to wrap it with some shipping tape just to squeeze it together so that the whole thing is held down nice and tight. Before I do that, I'm going to remove the excess bag material. And there we go. So that's all ready to be taped up, and we'll go put this on the power supply, charge it up, hook it up to the motor, and see how it does. Okay, so now we're going to go ahead and tape this up nice and tight, and that will put pressure between the two plates. The main reason we wanted to seal this in this bag like this is to keep the electrolyte from evaporating, to hold that in there over the long term, because you really don't want your electrolyte to evaporate on you. Okay, so I'm going to be testing this cell over a long period of time in different environments, and because of that I decided to put it in heat shrink. So this is PVC clear heat shrink. This is really tough stuff, and I'm going to go ahead and just heat shrink this around the cell so that it has something stronger than that shipping tape to give it strength over its lifetime. So go ahead and slip it inside of here. Cut off the excess after I shrink it down. There we go. Go ahead and remove the insulation here on the ends and put a charge on this. Okay, so what we have here is a multimeter connected to the capacitor to give us our voltage. One showing the milliamp draw to the motor. And I'm going to go ahead and start a timer here as well. So it's fresh off the charge over here from our power supply. We'll turn that off. It's not connected right now. And we've got our timer. We've got 40 milliamps or so to the motor, as well as our voltage across the capacitor. So this is actually the measurements you need to actually calculate the energy that's in this supercapacitor. And I'm probably not going to do that on this video just because I don't trust it yet. I think this thing needs to go through quite a few cycles of charge and discharging before we actually come up with some calculations as to what the energy density in here is. I've heard all kinds of reports and rumors, everything from these lessen in energy capacity after, you know, a few hundred cycles or whatever, to that they start increasing in energy capacity after you've done 50 charge and discharge cycles. So I don't know really what to think at this point until I do more tests myself, but you can see here we have a pretty steady over 30 milliamp current draw. We're 1 minute in, we're still above 1 volt on the supercapacitor. So I'll let this run down here for the remainder of the video. And we'll go ahead and I'll keep experimenting. This is very early stages for me on this research. I've got all kinds of material here that I want to test. I've got some stainless steel mesh in different sizes. I want to try using the stainless steel mesh instead of the aluminum. I've got some I also have this graphfoil material. This stuff is used for making gaskets, and it's very interesting material. It's very, very conductive. It's just a perfect conductor, but it is flexible graphite. So I've got a lot of stuff to experiment with. It's very early stages of experimentation for me on this. But okay, we're at 2 minutes. We're at 0.9 volts, drawing still 30 milliamps, 32 milliamps. 2 minutes in. I'll go ahead and prop this up with something and let this experiment run. So it looks like this motor likes to pull around 30 milliamps, you know, at anything around a volt. This is going to get down and probably keep running this motor down into half a volt or less. So we'll let it run and see. Three minutes, 30 milliamps, 0.8 volt. It's really starting to hold here at around, 0.8 volt very nicely. So, yeah, this may run quite a while.
Este tipo de tradução especial está sendo útil? Espero que sim. Contribua com o canal, faça um Pix, R$ 10 mensais, ou como preferir ajudar. Também, curta e se inscreva. LegDub Universe. Obrigado.
All right, we're at 5 minutes in. It's pulling 27 milliamps, and it's at 0.6 volts. So it's down to almost half a volt here. The milliamp draw is still holding fairly, just keeps hovering around 30 milliamps as the voltage drops. I kind of expected to see the current draw on the motor drop a little more than that and for the RPM to slow down a lot more. But anyway, I will let it keep running. I may run out of camera memory here on my memory card or battery on my camera. We'll see how this goes.
Este tipo de tradução especial está sendo útil? Espero que sim. Contribua com o canal, faça um Pix, R$ 10 mensais, ou como preferir ajudar. Também, curta e se inscreva. LegDub Universe. Obrigado.
All right, so we're at 10 minutes in, and we're almost down to a quarter volt, 22 milliamps on the current draw. So this thing has run 10 minutes, and you know what's interesting? As this voltage gets lower and this thing goes down, who knows how long this thing would really run at the bottom end of this. I don't have time to keep experimenting with this setup today, but I will go ahead and mark this down as its first charge and discharge cycle. I'll keep cycling it. I'll see if the capacity goes up, down, how it changes over some time. Very, very interesting. All right, guys, let's all keep experimenting.